So we're getting into 10.2, which is the law of cosines. All right. And the law of cosines, again, is also on your chapter 10 formula sheet. Your chapter 10 sheet you can find on Canvas. Okay, let me pull it up real quick again if you don't know where it is. On Canvas, right? This week. It's also under important documents, chapter 10 formulas. But I'm just keeping it probably here for all of our chapter 10 stuff. 10.2 is what we're doing today, law of cosines. So you can find this if you want. And it has all the formulas that you can use on like quizzes and exams and chapter 10 stuff. So if you don't know the quadratic formula by now, it is here. The law of sines is here. It's actually upside down from the law of sines that we used, but you can flip the law of sines upside down and it doesn't matter. You sleep next to your formula sheet. Okay, that's great. And then law of cosines, what we're getting into. Everything else is all complex numbers with trigonometry. All right, which will be the last section that we talk about. Yeah, I didn't realize when I uploaded this sheet that I forgot to update it from last year. And last year I was using a different book, which it was chapter 8. I was hoping nobody would notice. So this is what we're talking about today. Okay, so law of cosines, as you can see, looks a little familiar, right? If we just block, we just forget about this highlighted section. Forget about this highlighted section. What is this, right? A squared plus b squared equals c squared. The law of cosines is essentially just like a generalized Pythagorean theorem. Okay. And again, there's a cool place that it comes from, but as you can imagine, we use trig, we use substitutions, we set things up, and you get this. So it's essentially Pythagorean theorem, just for any triangle, which is why there are 3 of them. Pythagorean theorem, there's only one because it's a right triangle. But here, there are 3 of them because you can orient it kind of any way that you want. All right, so here we go right here. Law of cosines. So again, just like you have on the formula sheet, you can arrange it in any order, but essentially it's just a squared is equal to the other side squared plus the other side squared. These can be in any arrangement for law of cosines. Any order. You can have A over here, you can have B over here, you can have C over here. That just means you need the other 2 on the right-hand side. Okay? And then the new part is that you get minus 2 times these 2 times the cosine, C times cosine, looks kind of weird, of the angle opposite the left-hand side. All right? And this is used for solving different kinds of triangles. So sometimes you can use the law of sines. Sometimes you can use the law of cosines. Sometimes you can use both. But one of the more interesting things about this section is when you get to the homework problems that don't say use law of cosines to solve this problem, it's just solve this triangle. And do you have the information for law of cosines or do you have the information for law of sines? All right. So this is one way of looking at the formula. Again, there are 2 other ways that are in your sheet. Sometimes we'll also have to be solving for the angle. So if you want to rearrange this formula to solve for the angle, you can do that as well. But let's just get into some triangles. Okay? And the good news is there's no ambiguous case for law of cosines, only law of sines. Right? It's only that side angle for law of sines that can cause problems. No solution, 1 solution, or 2 solutions. Everything in the section is just going to have 2 solutions. Sorry. Everything in the section is going to have 1 solution. So we're good to go on that. Example 1. Okay, solve. Again, there are a whole bunch of these. Look at them in your identity sheet. All right, solve these triangles. Part A, give you a picture. Again, alpha, beta, gamma, and then ABC. Remember, ABC is always the side opposite that angle. So A is going to be 10. A is opposite alpha. And B is going to be 12, opposite beta. And here, gamma is 30 degrees. So say you love the law of sines. And the law of sines is certainly less messy than this, right? This has a lot more letters in it, a lot more things going on, law of cosine does, than law of sines. So say you love law of sines, even without the ambiguous case. Say, I'd like to use the law of sines here. So remember, law of sines says, how do we start with the law of sines? We start with the law of sines because, again, this is the law of sines, right? We need a side and its opposite angle. And that's how we start. And then we just find one more unknown on the right-hand side and one more known. So if we were trying to use the law of sines here, we'd say, okay, we need a side and its opposite angle. But notice, right? 10, we don't have alpha. 12, we don't have beta. We have gamma, but we don't have C. So you can't use law of cosines, or you can't use law of sines here. All right, we have to use law of cosines. Start with A. Yeah, that's a good way to do it, right? Because we don't know A, but we know the other two sides, and we know its opposite angle. Okay, so that's what we're going to do. We're actually going to use this form of the law of cosines. Okay, so what I would recommend is I would recommend writing down the formula, because there's a lot going on here. Writing down the formula and then just doing it one thing at a time. So a squared is equal to b squared plus c squared minus 2bc times cosine of a. All right, and again, we have b, we have c. Oh, oops. This is not a. This is c. So we don't want this formula, right? Because we don't know that angle A. Oh, I'm trying to be consistent. Right? Call it alpha. Trying to be consistent with the book. We don't want this formula because we don't have alpha, and we don't have C is the thing we're trying to solve for. Okay, so we just use the other formula, right? If you pick a formula and you start plugging things in and go, wait, this formula is not going to work. That's okay. Just move on and find the one that works. What are we trying to find? We're trying to find C because we have its opposite angle and the other two sides. So you look at the formula sheet and say, okay, we need the C one. So C squared is going to be essentially basic Pythagorean theorem, right? A squared plus B squared minus 2AB cosine of capital C or gamma. You can use both. All right. Yeah, you got me excited, Alex. So what we have here then is the other one. C squared is A squared plus B squared minus 2AB. And again, the things multiplied here are always the same as the other things added here. All right. Times the cosine of the opposite angle, which is gamma. And this is good, right? Because we have A is 10. We have B is 12. We have gamma is 30 degrees. Okay. So now we just start plugging things in and solving. Again, since we already know we're solving for C, if you wanted to take the square root right away, go for it. All right, C squared is equal to all that. If you're solving for C, you need to take the square root of both sides. And we take the square root of both sides. Remember, you need plus or minuses when solving equations. But we're not going to use plus or minuses here because we're not going to have a negative side to our triangle. Okay? But just algebra-wise, right? Algebra-wise, there are two answers to this. A plus or minus on the square root. But we don't need the minus here. This is why we're not writing it. So A we said was 10, so we're going to have 10 squared, or 100. Plus B we said was 12, so 12 squared, 144. And then we have 2 times A, again, which is 10, times B, which again is still 12, times the cosine of gamma, which is 30 degrees. And you could go on and solve and get an exact answer. You're going to get 244 right here. You're going to get minus 240 times root 3 over 2. You could simplify this and get an exact answer. But in this chapter, we only really care about approximations. Okay? So you can approximate in both of these sections, right? We already did it for 10.1. but we're going to do it in 10.2 as well. So instead of simplifying, I would just type this straight into my calculator, okay? Just type the whole thing into your calculator and see what you get. We have the square root of, I never actually show anybody this, but I don't own a calculator. You could use your phone, but when I do things for a calculator, I just type them into Google. They have like the square root of 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 30 degrees. Google does default to radians. And you can get 6.0128. All right. And again, just like in 10.1, just like with law of sines, I like to give 4 decimals originally, but in my answer, I'm usually only going to write 1 decimal, just like the book. Okay, so we found what C is equal to. And again, just like in 10.1, if you want to box this answer right here, you can, but a lot of times it's a little easier to just fill in the triangle as we're solving it and put all of our answers there. Okay, so we found one thing. And now, as soon as we find one thing, I think this is true literally all the time, you can use whichever formula your heart desires. Okay, so if you want to use law of cosines, if you want to use law of sines, you can use either one now. Okay, because we have enough information. Right? We could use the law of sines now because we have a side and its opposite angle. Or we could keep on using law of cosines. Okay, so I'm going to use law of cosines just because this is the law of cosines section. And we're really just going to, show you how to use the formula. So let me write that down. Next, use law of cosines or law of sines to find the last piece of information. Well, not really the last, but it's kind of the last, right? Because once we find the other angle, then we just use the fact that they add up to 180 degrees. So we only have to use one more formula. Law of sines is usually quicker, by the way. But make sure, be careful with law of sines that you are using the right angle. Because the law of sines, you can get 2 answers for your angles. Only one of them will always work because there's no ambiguous cases here. You have to make sure you choose the right one. All right? Okay. So we're going to use the law of cosine. So again, you have to identify which law of cosine do we use? So which law of cosine formula? We have all 3 sides, and we need to find either beta or alpha. Okay, so you just consult your formula sheet. We have all 3 sides, so that doesn't matter. We're solving for beta or alpha, so we need to use an equation that has beta or alpha. Okay, so you can use the first one or the second one. Right, so let's solve for alpha. I don't know. We'll use the first one. Okay. A squared is equal to b squared plus c squared minus 2bc cosine of the opposite angle alpha. And we're solving for alpha. So you have 2 choices here. Okay, and I think this is important to remark on. If you want, you could plug everything in and then solve for alpha with numbers. Or if you want to solve for alpha right now with all the variables and add this as a formula to your formula sheet, you could do that as well. Okay, here's what I mean, right? If we're solving for alpha, we could subtract b squared and c squared from both sides. We get a squared minus b squared minus c squared is equal to negative 2bc cosine of alpha. And then divide both sides by negative 2bc. That would give you that the cosine of alpha is equal to a squared minus b squared minus c squared divided by negative 2bc. If you want to write this on your formula sheet, you can. Or again, if you could multiply the top and the bottom by a negative and get a slightly nicer version, or you can just do this every single time. So either way, what do we have? We have the cosine of alpha is equal to a squared, and remember a is 10, so 10 squared, minus b squared, we said b was 12, minus c squared. I'm going to use the decimals here so I get a more exact answer. Okay, more precision is usually better. divided by negative 2 times b, and b again we still said was 12, times c, which is still 6.0128. Okay, we need to take the inverse cosine of that. Let's actually do the inverse cosine in this step. So alpha is going to be the inverse cosine of all this. So again, I said usually this is a pretty straightforward section for most students, but not everyone, right? So if you struggle with it, that's fine. But some of the hardest things are just plugging things in correctly and typing it into your calculator correctly, right? So we're going to have the inverse cosine. This whole numerator needs to be in parentheses. The denominator should be in parentheses. If you want to do it one step at a time, you can, but you will lose a little bit of precision, but it's okay. So one step at a time or all at the same time, doesn't matter. Just be careful with your parentheses. Okay, so for example, let's finish the problem over here so it's all on the same page. Type that into our calculator. What do we get? You're going to get something messy, right? Again, you can also use arc cosine if you're doing something like this. Of the numerator, which is 10 squared minus 12 squared minus 6.0128 squared, parentheses, divided by the denominator, negative 2 times 12 times 6.0128, and denominator and arc cosine, so you can see the parentheses are going wild right here. And again, Google naturally gives it in radians, but we can multiply by 180 divided by pi to get it in degrees. And we get 56.2591 degrees. So, again, remember, if the book gives you a picture, the picture is going to be correct 9 times out of 10, unless it doesn't specify. So A is 56 degrees. Oh, well, my pictures aren't going to be that great, but A is going to be about 56.3 degrees. All right, and now we have two angles. We can find the third angle because they all add up to 180. So we go down here and say, okay, beta is going to be 180 minus alpha minus gamma. So again, you just type that into your calculator again. What is 180 degrees minus alpha, which is 56.3 degrees, 2591, minus gamma, which is 30 degrees, and you're going to get 93.7409 degrees, or 93.7. Okay? And now we have all three sides of our triangle, all three angles of our triangle, and remember, one of the best ways to check your answer in both of these sections is, does this triangle make sense? Is this triangle possible? And for law of cosines, it should always be possible. If you did things correctly, law of sines has that SSA ambiguous case. So we would find the biggest angle. What's the biggest angle? 93.7. Is that opposite the biggest side? 12 is the biggest side, good. Smallest angle is 30 degrees. Is its opposite side the smallest side? 6? Yeah, good. All right, everything's rounded correctly. We can be reasonably sure that if we made a mistake, we didn't make a huge mistake, probably. And that's how you do these problems. Okay, so we're just going to do one more problem today, and then we're going to be done a little early. Okay, quite a bit early. So that's this part A, right? It showed both ways to use law of cosines. You can use law of cosines to solve for a side, which is usually a little quicker, or you can use law of cosines to solve for an angle, which is a little messier. Right, depending on what information you have available. And this is from my other class. We were throwing one of my students into the air. This is his position function, but not in this class. Okay, let's get a fresh sheet of paper. All right, 1B, we're solving another triangle. Here, this triangle is not a picture, but A is 20, B is 25, and C is 18. So if you want to draw a picture, you can go draw a picture. Okay, but we don't need a picture for this one. But I like pictures. Okay, so I'm going to draw a picture. Just going to draw some triangle. I don't know what it's going to look like. Alpha, beta, gamma. So A is the side opposite alpha. That's 20. B is the side opposite beta, that's 25. C is the side opposite gamma, which is 18. So this is an interesting situation. This is the SSS situation. We only have side, side, side. Law of sines, again, wouldn't help us. Because for law of sines, we have to find an angle and its opposite side that we both know. We don't know any angles, so we don't know any of these pairs. Makes a good case for law of cosines. Okay, so again, we just go to our cosine sheet and say, okay, we have three sides. Which law of cosines formula should I use? And the answer is any of them, right? We have A, B, and C. We can use any formula because every formula only has one unknown, just alpha, beta, or gamma. Or again, this sheet has capital A, B, C, but they're equivalent. So you can use any law of cosines formula that you want here. Okay? So, I don't know. Well, let's use the Pythagorean theorem one. I like that one, right? A squared plus B squared equals C squared. But again, right, this is only for right triangles. These are not right triangles. So we have to use law of cosines. Minus 2AB, again, the A and the B are always going to be the same thing that's on. Whatever goes here is always the same thing that's already on the right-hand side. Times the cosine of gamma, the angle that's opposite this side. I'm explaining the formula to you, but you will have your sheet, so you don't need to memorize these formulas, but there it is. And now we just plug things in. So last time I solved for gamma first. This time I'm probably still going to solve for gamma first, okay? So subtract A squared and B squared. It's negative 2AB, cosine of gamma. Divide both sides by negative 2AB. You get cosine of gamma. Equals C squared minus A squared minus B squared, all over negative 2AB. And then take the inverse cosine of both sides. You get gamma is equal to the inverse cosine of that whole right-hand side. And now I plug in numbers. Okay. C is 18. This becomes 18 squared. I don't remember what that is off the top of my head. Minus A squared, A is 20. Minus 20 squared. Minus B squared, 25. Okay. Divided by negative 2 times A, which is 20, times B, which is 25. All right. And you type that in your calculator, and you hope you don't mess it up. Or again, you can do it one at a time. So, what are we going to get? Well, let's ask Google. Inverse cosine of our numerator, 18 squared minus 20 squared minus 25 squared, divided by our denominator, negative 2 times 20 times 25. And again, that gives us an answer in radians, so we have to convert it. Multiply by 180 divided by pi. We're going to get 45.4927 degrees. So we just fill that in. Gamma is about 45.5 degrees. And again, just like last time, as soon as you find the first piece of information, you can now either use law of sines or law of cosines. So last time I used law of cosines to get more practice with law of cosines. This time, let's use law of sines to see what that looks like. Okay? So remember 10.1, law of sines, just like your exam. You need to pick a pair. This is not 455. There's a dot right there. Pick a pair of a side and its opposite angle. So this is the only pair. We're going to get sine of gamma, which again is about 45.4927. It's usually best to use more digits when you're using it to solve something, divided by C, which was 18, is equal to, again, we can choose any pair, beta and B, or alpha and A. We can choose either pair because in each pair, we know one part of the pair and not the other. Okay? So let's find alpha. Why not? Sine alpha divided by A, which is 20. That's not an alpha. That right there is a gamma. I don't teach Greek though, so it's okay. Sine alpha over 20. Multiply both sides by 20. You get sine alpha is equal to 20 times the sine of 45.4927 degrees divided by 18. And again, it's a good idea when you're using law of sines. What does that right-hand side look like, right? The right-hand side is 20 times the sine of 45.4927 degrees divided by 18. That right-hand side is 0.7924. Because remember, if that right-hand side were something like 5 or 7, any number bigger than 1 or smaller than -1, we'd say, there's no answer. That'll happen in 10.1. It will never happen in 10.2. But on your final exam, right, I'm not going to tell you whether it's 10.1 or 10.2. So on your final exam, you're just going to have a bunch of triangles to solve for that portion of the exam. And you have to either use law of sines or law of cosines. Law of cosines will never have an ambiguous case, but law of sines might. Okay, so it's just a good habit to stay in. So we know there's going to be 1 or 2 answers. If it were law of sines, we know there's only going to be 1 answer. We can get the alpha is approximately equal to the inverse sine of that, converted back 2 degrees, which is about 52.4105 degrees. Okay. So again, does this answer make sense? Or do we need alpha prime? Okay, good to tie in everything with 10.1 law of sines. So 52, that's a little bit bigger than 45. And its opposite side, 20, is a little bit bigger than this opposite side, which is 18. Okay. If we found alpha prime would be like almost 130 degrees. And then we'd have a real big problem when it came to beta. Okay. So this is what we want for alpha, 52.4. All right. So we found alpha, found gamma. Beta is not too bad, because beta is just always going to be 180 minus alpha minus gamma, right? That's 180 minus 52.4 minus 45.5 is going to be 82.1 degrees. All right. And if you chose alpha prime instead of alpha, from using law of sines, remember there are infinitely many solutions to this equation. There are 2 solutions in the interval 0 to 2 pi. There's only 1 solution that makes sense for a triangle, for this triangle. Okay, so we have all the sides, we have all the angles, we do our gut check. What's the biggest angle? Biggest angle is beta. Is the biggest side B? Yep. Smallest angle is gamma. Is the smallest side C? Yep. Good. Gut check is successful, and that's our answer up here. Or again, if you want to box your individual answers like this is also an acceptable. All I care, I try not to be nitpicky on how you express your answer. The biggest thing is, can I see your answer quickly? I don't want to have to play Where's Waldo when I'm grading your exams, right? As long as it's clear, either do this or just fill it in right here. You'll be good to go. All right, and that's it. That's it for today. We're gonna have a short day. There's 2 more examples in the whole section, so we'll finish up on Monday. And either Monday will be a short day, or we'll start going a little faster and move up the date of the final exam. I might make a poll or something for the class over the weekend. So stay tuned for that. I'll send it out on Canvas and Discord if I do. All right. But that's essentially everything that's going on in this section. If you have questions, let me know. Otherwise, have an amazing weekend. Good work on the exam. There were some very high scores on this exam. So have a good day. Enjoy the nice weather too. It's really nice outside. Oh yes, Tyler. Thank you. Extra credit for the extra credit question today. Tell me what you prefer: law of sines or law of cosines. 10.1 or 10.2. Which do you prefer? All right. Thank you for the reminder. And then after you've sent me on Discord law of sines or law of cosines, see, It's not even, then we'll be done. It's not even an easy answer for me because law of sines is quicker, but law of sines has the ambiguous case. So I don't even know which one I like, but they're both good. That's why we do both. Got a really nice picture coming up too. Look at that beautiful picture with a little boat on a little port. I got a dock. I got some seaside buildings. We'll be doing that next time. Anyway, have a good one. Bye-bye.